Okay, let's look at some ways to filter and manipulate data in H2O. Now the R and Python APIs differ a bit for this functionality, but that's deliberate. It's so in R it will feel like the R that you're used to, and the same for Python pandas. So I'm going to start with R. I've started up H2O and I've imported the airlines dataset that we looked at last week. And I've used split frame to put 80% into training, 10% into validation, and the remaining 10% into test. If I just wanted the first 80% of that data frame without the random sampling, then I just write 1:35,255, or however many rows that you want. That's simple. Let's just look to the side here. If I do H2O ls, it shows me what data objects are on the H2O server. And you can see I have 5 there, and all of them have horrible names. So I can't tell which one is my first 35,000 rows and which are train, test and valid. So I'm going to use assign just to rename. We can use the same approach to filter columns. By default, the airlines data has 31 columns, but if I just wanted the date fields, which are the first 4 columns, I could use this command. Notice it's rows, then columns, just as in normal R. And if I just wanted to get the origin and destination airports, those 2 columns, I can give them by names. I don't have to use numbers. Okay, and we'll just check there. Yes, we have 2 columns in our airports frame, 4 columns in our dates frame. Okay, and if I wanted to put them together, this is where I use h2o.cbind. dim shows us both the number of rows and the number of columns, so you can see we've got the same number of rows as we started with, and we now have 6 columns. Next, we're going to use H2O rbind to join rows together. So in this case, I'm going to put train, test and valid back together. And if we compare, you can see we have exactly the same size frames. Almost 44,000 rows, 31 columns. However, the data is different. If we look at the first, well in this case 6 rows from each, you can see the last 2 are different. What's going on is that when we do H2O rbind, it's going to take all 35,000 from train, then the 5,000 from valid, then the 5,000 from test, and concatenate them in that order, which is a different order because of the random sampling from the original data. Oh, let's just confirm that's what's happening. You can see the first 6 rows of train are the first 6 rows of the restored data. Okay, switching over into Python and bringing in H2O. The pandas and numpy references will come in later. Initializing H2O, importing the data, splitting it into 80%, 10%, 10%. Okay, and again, if I want exactly the first 80% without any random sampling, it's almost the same command. But one difference with Python, you need that colon there. You can't have a blank argument. And I assign a name to it in the same way. H2O ls is also available in Python, so you can see my variables there, including the one I've just created. The data has 31 columns, and to filter by columns, again, very similar to how it was in R. We need the colon rather than leave something blank. The colon here is meaning all rows, and Python counts from 0 instead of 1. So 4 date columns, 2 airports, and just as in R, you can specify either numeric columns or the column names. Okay, when we want to join columns together, you give one of the frames, then .cbind, and then the other. So the first four columns are the airport. Sorry, the first two columns are the airports, origin and destination. Then the next four columns are the date-related columns. rbind is very similar. Here I'm using a list so I can bind 3 data frames together. So the first one is on the left side of the dot, and the remaining 2 go in a list as the argument, giving us a data frame the same size as what we originally started with. Okay, let's pause for a quick test, and then we're going to come back and look at merging.